Good evening all. Myself Dr.A.Vaniprabha, Associate Professor, EC Department, SNS College of Engineering. Today we are going to discuss on applications of steady magnetic field. Steady magnetic field. It is actually a static magnetic field or a magnetic field that does not change over time. It is characterized by a constant magnetic flux density or magnetic field strength at a given point. Important concepts to be understood so as to have a clear idea of steady magnetic fields. One is magnetic field lines, another is magnetic field strength, next is magnetic flux density, and next is magnetic force. What is magnetic field lines? In a static or in a steady magnetic field, the magnetic field lines are continuous. It forms a closed loop. The direction of these lines indicates the direction of the magnetic field at any given point. The density of the field lines represents the strength of the magnetic field, with closer lines indicating a stronger field. Next is magnetic field strength. The strength of a steady magnetic field is typically measured in Tesla or Gauss. 1 Tesla is equal to 10,000 Gauss. The magnetic field strength determines the force experienced by a charged particle moving through the field. Magnetic flux density. It is often denoted by the symbol B, and it is a measure of the amount of magnetic flux passing through a unit area perpendicular to the direction of the magnetic field. And this flux density is directly related to the magnetic field strength, and it is measured in Tesla or Gauss. And the last is magnetic force. Charged particle moving through a steady magnetic field experiences a force known as the magnetic force. This force acts perpendicular to both the direction of particle motion and the magnetic field. The magnitude of the direction of the force depends on the charge on the particle, its velocity and strength and direction of the magnetic field. The main application of steady magnetic field covers MRI, MRS, magnetic sensors and compasses, particle accelerators, magnetic shielding, etc. So the first application is magnetic resonance imaging, shortly named as MRI. It is a medical imaging technique that uses strong static magnetic fields and radio waves to generate the detailed images of the internal structures of the human body. The static magnetic field aligns the protons in a body, and radio frequency pulses are applied to create signals that are detected and processed to produce high resolution images. Next is magnetic resonance spectroscopy, MRS. Is a technique used to analyze the chemical composition of substances, particularly in biological samples. It utilizes steady magnetic fields to detect and analyze the magnetic properties of atomic nuclei, providing valuable information about the structure and materials. Next is magnetic sensors and compasses. Steady magnetic fields are utilized in various sensing applications. Hall effect sensors, for example, measure changes in magnetic field and are used in applications like current sensing, position sensing, and proximity detection. Compasses also rely on steady magnetic fields to provide navigation and orientation information. Next is particle accelerators. Steady magnetic fields are essential components of particle accelerators such as cyclotrons and synchrotrons. These fields are used to steer and control the trajectory of charged particles as they are accelerated to high speeds, enabling scientific research in particular physics and nuclear medicine. Next is magnetic shielding. Steady magnetic fields can be used for magnetic shielding to protect the sensitive electronic component or environments from external magnetic interference. Shielding materials with high magnetic permeability are employed to direct or absorb the magnetic fields, including their magnet on their protected area. Thank you.